Ding. All right. So everyone could see this? Yeah. Yeah, you can see it. All right. So taking a look at what we're looking, take a look at what we're looking at. All right. We have today, all we're talking about that's extra is outliers and skewed data. Okay. So with that, if we're looking at it, an outlier is like somebody that is the extreme. All right. The outlier is it's, you can say, like a data point that's extreme. So a data point that's extreme, that's like the person that gets a 1600 on the SAT, or the person gets like a 200 on the SAT. Those are extreme values. Very few will do that, less than even 1%. Okay. And when you have an outlier, it messes up your data. In fact, outliers that are more than 3.4 sigma to the right, or negative 3.4 sigma to the left, right? Anyone that is that far to the left or right, it's extreme, and we're going to let's see, omit or cut. No, I got to use omit. Omit means you just don't include it, so not included. Okay, so we're going to omit that data point. Because we're using statistics to understand the scenario. So we have to get rid of the ones that are just way off the chart in either direction, positive or negative. Okay. So with this, if we omit it, so outliers, we're going to call as insignificant. Why? Because we're going to omit it. We're not going to include it. So anything that is way outside of the data that I'm collecting, I can actually say it's insignificant because it's just way too far out, right? It's insignificant because it's so far different than everybody else, we're not even going to count it. Otherwise, we'll get these skewed situations down here, okay? So let's see. If our process for finding it is going to be exactly the same. And the reason why I put this down here, remember in our z-scores we were doing just before this, and with the z-score, I gave you one that was positive 3.48, right? So when the z-score is positive 3.48, which relates to how many sigma values it relates to its sigma value here. This is where we can see that the z-scores, we can apply that to the outlier idea. Because when the z-score is greater than 3.4 or less than negative 3.4, then it's an outlier. It's way out there. And let's see if that makes sense with this. Because look, 3.48 z-score is 99.97%. That person on this scale is way over here. Is way over here. And anything to the right is an outlier of this point. Anything to the left is also an outlier. And we don't know what value that is, right? We don't know what value that is, but we can be just given the z-score and figure out, yeah, that's like an extreme, okay? So anytime you get a z-score, so z-scores, right, plus or minus that 3.4 are well, they're outliers, comma, they're insignificant to the other data, and we're not going to include it. Not included. Okay. That's key. So the z-score is, if it's negative 3.4 or further, if it's greater than 3.4, way up here or way down here, we're going to just take that data point out. We're going to say it's not significant because it's just too different. It's too good or too bad. It's very, very rare for someone to score at the like 99.99 percentile, right? So we don't count those folks. All right. So the other bits, James, you're unmuted. You got a question? No. Okay. No problem. All right. So this is what happens if you don't omit outliers. You end up with data that is really skewed. Skewed. Skew means it's like it's abnormal. It's not typical. All right. So atypical, abnormal. Right? It's weird. It's just weird. It doesn't look like a regular normal curve. Okay. And yes, sir. I can't read it. Oh well, that's actually that's because of my writing. I was saying that it's atypical, it's abnormal, it's weird, right? That's what the word skew. The word skew. I was just trying to give a bunch of different words for it. Okay, that's it. So this is it. The skew left means that, okay, for some reason there was a bunch of kids that, on the SAT they scored 101, 102, 206. They scored really low scores. There were so many kids that scored low SAT scores from this one group that the entire graph is moved over to the right because we had to make room and there were more than there should be over here. This is like a tail, okay? So you could think of it as, it's also called tail left, okay? And if you really wanted to, you could make this your cat. That's my worst. That's sleep deprived cat. And this is like her tail. My cat needs to go to the vet. I don't know what that is. Her other foot. Something's happening. The tail goes to the left. Okay. All right, James, you're still unmuted. Okay, so skewed left when we have a, you can call it like abnormal amount of low scores. Okay. It's skewed left because the tail goes left because there's more people that were over here. And now it's like a raccoon cat. It's like a lemur. Sorry, that's distracting. Or maybe it's good. Maybe it's good. You should see me at 3.5 hours of sleep. I did the senior trip one time and came back and taught. I got into school at like 4 a.m. and then taught at 8. Oh my God.
Honestly, I would call a substitute to come and teach the next day.
I think I was out of sub days. And when I don't have sub days, Dinosaur Cat. Thank you, Roseli. When I don't have sub days, it costs me like $550 to take a sub day. It's ridiculous.
Oh, wow.
And the sub doesn't even cost that much. It's just the district. They love teachers. So yes, sir. James?
I didn't finish the last time.
Okay. All right. Sounded like you were talking to somebody, so we can have them kind of leave you alone for the last 10 minutes here so we can go quick. All right. So skewed left, I'm going to leave right here. Maybe I can leave it like that.
I finished.
Okay. Yeah, it wasn't too much more, right? All right. Guess what happens with skew right? Skew right is like West Campus, guys, because West Campus does better than the average. Most of you are better than the average, right? There's not a lot of D average students at West Campus, right? There's a lot of B plus average students and probably A minus average students and A, right? But we would say then that this is skewed right because it has an abnormal, these are the straightforward topics, amount of high scores. Okay, that's because you had all these kids that because they go to West Campus, they did pretty dang good. Here's usually where the mean is, and there's so many that did well that it is skewed right, and it's like, also think of it as tail right. Actually, if you write that tail right, that is going to help you remember in tail left, because you may think that skewed right means the whole curve moves to the right. But no, actually, just the tail moves to the right. Okay, all right. Maybe we should do a homework problem. That's all I had for you today. Give me a thumbs up, sideways down for that. Thumbs up, sideways down for the additions, right? Okay. And it's no different process than what we did in the beginning. The beginning is always going to, just like we had here, with our second student. With our second student, we had this set of data points, or this data point, our mu and our sigma. And all I did with that was go and put it into my z-score to find the decimal, which gives me the percentile rank. Okay. So z-score is all about percentile rank. And if you found that somebody, scored greater than 3.4 sigma or less than 3.4 sigma, so these are z-scores, right? The z-score of plus or minus 3.4, it's an outlier. It's an outlier, and we don't include it. Okay? It's insignificant because it's just too good or too bad. It's too bad. All right. I say we do a little bit of homework. Let's do it. All right, I'm going to keep recording for this. So all this is on the, it'll be posted later. I'll do it right after this. All right, let me get my other screen going here. Come on now. Thank you. All right, and then let me just share the doc. I'm just going to share a problem from the doc, okay? So I'm going to put it in the chat so you have the data points. And let's look. Complete all. Okay, number just find the z-score of a value. Okay, perfect. Let's do number one. So I'm going to go ahead and copy this and put it in our chat, and then we'll all just look at it. So if you don't have that open, this will get us everyone there quick. All right. A normal distribution has a mean of 84. Okay. So it has a mean of 84. All right. So let's see. We have a mean of 84. Standard D we call sigma. That's how we show the standard D. Standard deviation is sigma. And that is 6. All right. We have an X value. This is just like the score of 76. We need to find the Z-score and then see if it's significant or insignificant. Okay. So now let's just see that we're going to do the same thing we've been doing. I want you to go ahead and put, they're in different order than how I wrote it last time, but no worries. We know that it's x of 1 minus mu over standard sigma, standard deviation. Okay. Okay. (76 minus 84 over 6). What is that going to be? Negative 8 over 6. So we end up with a z of negative 1.33 repeating. Is that right? 1.33, negative 1.33 repeating. Good. All right. So I hope that it seems like it got a lot easier. I hope. If not, that's all right. We can check in at a 9 o'clock meeting if you need to. But we've done everything now to have our z-score, and now we just have to find what percentile rank. Actually, they just asked us for the z-score. So first, I want to do the percentile rank, but tell me, all they're asking is this score considered to be statistically significant or statistically insignificant? Remember, outliers are insignificant because it's too far over from the mean. So this one, is it going to be significant or insignificant? Significant, insignificant. Which one? Good. Yeah. Right. So all you have to do is once you get your z-score, check, got it. Now we just compare it. Is it less than negative 3.4 or is it greater than positive 3.4? It's neither. It's in between it. Okay. And remember that this is in relation to, we have positive 3.4. We have negative 3.4. So negative 1.3 is like right here probably. This would be a negative 1.3. Okay. If I needed to find the percentile rank, which might be helpful for us all to do real quick, then I'm going to go to negative 1.3 right here. And then I need to add on that other 100th spot. So I need to go over so that it matches with the 3 cents here. And we get right there to 0.0918. So we know that this z-score, right? This z-score gives us the 9.18. Yep, 9.18 percentile. So if this was like a score and this person had scored 76, it's below the mean. We know that it's pretty low, and actually it is really low. That's somewhat based on our standard deviation as being, a reasonably large number. It's not tiny. Okay. All right. Hey, that's all you had to do for number 1. Let's see. We might have time for another one really fast. Let's see if we have it. There it is. Now I want to skip that one. Okay, let's do this one. Let's do number 3. This is number 3. And this one is slightly different. And I want to give you a taste on the different types of problems here. Here we go. Number 3. A patient recently diagnosed with Alzheimer's disease takes a cognitive abilities test and scores a 44.5. Okay. So that's their score is our x sub 1, right? And with that, we have 44.5. Okay. We have a mean of 52. We have a standard deviation of 5. Okay. And it's asking, look at the question. Look at the question, this next sentence. Really read that on your own. What's the last sentence? It's which scored higher. Now remember that we're going to find the z-score in the percentile from this information, but that is always telling us how many percent you scored higher. So if here's 40, let me see. Actually, it's not going to be there. So if here's our 52, here maybe is 44.5. So remember our z-score. The z-score is going to tell us what percentage we did better than. We did better than all those students. But the question is saying what percent of individuals scored higher than that patient. Okay. So once we find our actual percentile here, then we have to think about it. Well, I'm going to subtract it from 100 to see what is all this over here. All right. So let's go ahead and put this all together with z is equal to 44.5 minus 52 over 5. And just go ahead and do the numerators and divide by 5. And we get 44.5 minus 52 divided by 5. Okay. And we get negative 1.5. So that's our z-score. I'm going to let you do the rest to get the percentile. Once you have the percentile, tell me in the chat, once you have the percentile, what percent did better than you? This is a significant because it's only negative 1.5. It's not all the way to our negative 3.4. So since it's negative 1.5, we know it's significant. We got to count it. It's not an outlier. And now we just got to find the percentile from your z-score chart. All right. So here's the thing. Remember, this is going to give us our percentile. Whoops, that's not even close. Percentile, right? Then we have to see how many scored better than us. So once we get the percentile here, we're going to have to subtract it from 100. And that's going to say what percentage did better than us. All right, so let's see what is 1.5. 1.5 right here. It's 1.50, so I just have to go over to, thank you. Good. So I know my percentile from this. First I get, dang it, 655. 0.0655. And then I have to convert that to a percent. 6.55%. So this patient only did better than 6.55%. And I could see from that, what? How did you guys get 93.32? One sec. Did I miss this? That's why. That's why. This is actually 668. I think I was doing the last problem again. No, Isabel, I think you're right. You are right, because this would give us that value. 6.8 will give us 3.2. You got it. You got it. All right, so here was a percentile that all these values, remember, gave us a z-score. Z-score with the z-score chart gives us percentile. Gives us at a decimal, but we're not going to have an issue with that. We just move it twice, and we get 6.68. Ugliest numbers of the day. All I then have to do is subtract it from 100. Just made it into zeros so we can subtract it. Ugh. 0, 1, 9, 1, 9, 1, 9, 1. I actually kind of like that. 3, 3, 9. Nice. I don't know why that made me happy. It did. All right. So what percent did better than you? You have to find your percent and say, well, I did better than 6.68. So I know that, quite a few did better than me. 93.32% did better than you. Okay. That's actually quite a few of the problems. That's quite a few of the different types of problems. Woo! And we got 2 minutes to spare. Man, what should we do for 2 minutes? Leave early? I don't mind that. No? Yeah? Sometimes I think people can tell I'm looking at their screen and sometimes not. I don't know. It's kind of weird. All right. I'm going to go ahead and stop this video. I'm going to post this today along with my throwback video. So this will just be listed as today if you need to check it out and look for the specifics. Okay. So